Okay, let's take a break from fishing. I noticed here in this kind of like a side pool, kind of a low depression in the terrain where like water can just like fill up, and it doesn't really flow too much out here. That's why you see it becoming a little bit eutrophic, meaning a lot of the nutrients are starting to like a lot of nutrients are aggregating here, and you see that there's a lot of like microalgae. That's why it's so cloudy in the water and more greenish compared to like way out there where it's like all nice and oxygenated and blue. But I see some bugs down here, some pretty cool aquatic insects. Then we're gonna take a look at them right now. All right, first up, I'm seeing these things that are crawling along the rocks. Hopefully you can get a good angle at them. Those are Tricopterins, order Tricoptera, probably in the family Limnophilidae. I don't know, let's pull one out. Okay. There we go, Tricopterins insect species. This one's hunkered down in its little case. They make these cases out of debris from the environment, whether it's like little pieces of granite, little pieces of wood or decaying plant matter, and they use it kind of as a protective case, and they'll also pupate in there. Tricopterins are known as the sister group for the Lepidopterans, which are the butterflies and moths. So this group and the Lepidopterans share a common ancestor. They both pupate. They both have like a larval stage, and then a pupal stage, and then an adult stage. But Tricopterins are exclusively live in water when they're in their larval and pupal stage. Pretty cool though. So what many tricops are known for is grazers. So they'll graze on the algae that is accumulating in this pool. Since not a lot of water is moving through this pool, the water heats up more readily, which provides kind of like an anoxic environment for algae to grow in, and a lot of nutrients like accumulate here. So these are grazers, and right there, that thing swimming in the water, that's a predator, and we about to catch that right now. I'll show it to you close up. Good thing I got a net. Oh, he got the surface. He fucked up. Watch this. There it is. Boom. It's a pretty one too. Okay, what we got right here is a specimen in the family Dyticidae, or predatory diving beetles. And this one has an interesting pattern on the posterior portions of its elytra. So the elytra are the first pair of wings in beetles. Beetles are the most diverse order of insect group in the world. I think there are more species of beetle than there are in all other insects altogether. This one looks like a male, and the only reason I say that is because it's got these pads on its front legs like that. And those, I went to a workshop, and apparently those little pads are meant to grasp onto the elytra of the female. And apparently there's some weird sexual competition going on between Dyticid species. But this one is obviously one that you can find up here in high elevations. It's a predator, so it's diving around probably looking for little juvenile fish that have strayed their ways into this pool. Probably other aquatic insects. Not sure if it's going to be eating those tricops. It might eat some back swimmers, insects in the family Corixidae. Insects in the family Corixidae. But these diving beetles, along with another family of beetles known as the Hydrophilidae, they have these back legs, these natatorial legs. That's what they're called. Legs evolved for swimming, and that allows them to basically paddle their way through the water. So yeah, just a few insect fauna that you'll find in some of these side lakes, or these micro habitats from these high elevation alpine lakes. Got this little side pond here, experiencing a little bit of eutrophism, if that's a word, which brings algae, which brings grazers, which brings predators. All right, here we go. Hour and 15 minutes later, we're at this place called Garnet Lake, and yeah, it looks beautiful here too. It looks like there's a lot of deep blue sections here, so it's getting me a little bit excited, because I mean, this trip, that's where the fish are, in those deep blue sections of the lake. All right, let's get down there, get down to business. Oh, got one. Need to get the net. He's hooked pretty good though. Oh, that's a good one. Oh, he's a good one. I like this. Come over here. Let's go. There we go. Bam. Oh. And this is the species we was looking for. So, and with my experience with trout, it doesn't pay to actually like grip it really hard. They actually get scared and they're more likely to flap out of your hands, But yeah, here we go. Savelinus Fontinalis, otherwise known as the brook trout, introduced species here in the Sierras of California. If you look here, one of the main differences between this and Oncorhynchus is its jaw. It's much more acute angle of its jaw. Like basically has a bigger mouth is what I'm saying. Got a few pretty colors. You know, it's got these white margins on the edges of its bottom fins here. Fun fighting fish. And you notice like how it moves. If you saw how I was fighting it, how much that rod tip was shaking, and that's because of the way it moves and the way its muscles are arranged in its body. The myomeres, or the muscles of a fish, in this allow it to have what they call subcarangiform swimming, which basically is helpful and advantageous to these types of fish, because just like well, for example, those in the genus Oncorhynchus, which includes salmon, and many species are anadromous, you know, it helps them like swimming in from the ocean into freshwater systems such as mountainous rivers and streams, and having that subcarangiform type of movement basically allows it to kind of grip onto rocks and like really like kind of like slither through rocks and up rocks and everything. Like when you see them swimming upstream, they actually look more reminiscent of worms than fish. But I think this one's getting a little too traumatized. I'm gonna have to get the hook out and release it. But yeah, Savelinus Fontinalis, the brook trout, introduced species here in California, in the mountains of California, in the Sierra Nevada. But a fun fish to catch. Ooh, on the hookup bait. On the hookup bait. Oh shit. Oh, they one line about these. A good one too. Oh yeah. What's up? Oh, look at that. Getting the sunlight. It's a nice one right here. Let me get more in the water. Hold on. Oh, there we go. Salvelinus Fontinalis, the brook trout. Hopefully you got a good example of what that subcarangiform style of swimming look like. Very shaky. These guys also seem to have sharper teeth, I notice. Inside its mouth. Classic salmonid face shape of the face. Classic salmonid. Oh. Whoa. Chill. Oh, I don't want to swim there. Hold on. You good. Oh, there he goes. Boom. Bomp. There we go. I knew there had to be one here. The spot looked too juicy. Oh. Go. The Salvelinus special Garnet. Let's go. Oh, there it is. Oh. chill, 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 chill. There it is. Savelinus Fontinalis, the brook trout, once again, bringing them up from the depths. It's your boy Slice. All right, let's put it back. Oh, he's already unhooked. Oh, that's what's up. All right, bye. Oh, by the way, if you want to know what it looks like under there, here. Hopefully that looked good. You know, when I come to a spot like this, it just puts me in a really nice, comfortable place. Just because knowing that like what you're seeing here took millennia or millions of years to evolve. This type of ecological action, or this ecological example that you see here, where you have different plants taking advantage of different ecological niches or different resource niches to which benefits them and their species, essentially, whatever their genes that distinguish the biology of that species. And when I get back down to the city, I always kind of ponder, like, damn, like all these places that have everything developed over, like I wonder if back in the day if you would see ecosystems similar to this, similar to these zoning patterns, this wildness. But now you only find it really in places that are crazy remote, you know, and even then they're still being affected. But I don't know, it's just kind of cool to witness this sometimes. This is what rocks my boat, you know, stuff like this. I mean, if y'all know what I'm talking about, I mean, look, you got these like pine trees that are growing right here, and you can tell that these have been growing for some time. And then all this like ground cover layer right here, like this is probably like annual vegetation or ephemeral vegetation during the wet season, the snow season. Like depending on the soil, how well the water drains in the soil probably dictates what can live here. And then you got those bushes right there. Well, those look like willows. I think they're a type of willow. Maybe right there in that one spot is where water tends to accumulate, and it can access the resource to that water there. Same with that pine tree, same with those pine trees over there. And then these plants have evolved to just deal with the limiting resource of water, probably, and the well drainage of the soil. Soil drains really well here, so they've adapted a biology that's more or less short and ephemeral. They grow, reproduce, die off, cycle starts over again the next year. There's a lot of ecology, a lot of life stages, a lot of life strategies going on here, and that's what makes this place dope. Anyway, thanks for joining me. Until the next episode, remember, keep your decisions scientific, stay away from all the gimmicks. Peace up, peace out, learn something. Bye.